Hi everyone. So in this video I will show you how to solve the example 6 from our lecture note. So before we move to the step by step of the solution, let we try to understand what is the question asked here. So we have the problem, which is that airflow allow a thin symmetrical airfoil and generate boundary layer around the airfoil. The velocity outside or U stream velocity, which is that given that U stream is equal to 35 meter per second. So we try to get the data that they give to us first, and the boundary layer thickness at the trailing edge. So boundary layer thickness at trailing edge is equal to 2 mm, and they give the velocity profile for the boundary layer is sine velocity profile, which is that U over US is equal to sine pi Y over 2 pi, and they give the momentum thickness, and they ask to evaluate the drag on one side of the aerofoil. Okay, so we have the aerofoil, maybe like this, and then one side of, they just want us to determine the drag at one side of the aerofoil, which is that this one maybe from 0 to L, like that. Okay, so firstly, when they ask for drag, meaning that we need to look what is the equation for drag force. We know that from the lecture, drag force or FD is equal to the integration from 0 to L, which is from here, we integrate to L, is shear wall dA. That's the question for the drag force. So from here, what is the, we want to integrate this equation. So what is the shear wall? Shear wall is equal to mu du over dy at y equal to 0. And then what is du dy? Du over dy, what is the du dy? So we have the boundary layer equation, which is that U over U stream is equal to sine pi Y over 2 delta. So from here we have U equal to U stream sine pi Y over 2 delta. So I just write down here, we have shear wall, or maybe this one, or we could just put direct du dy. Du over dy, which is that this one, is equal to, we differentiate u is this one, okay, u is u stream sine pi Y over 2 delta over dx. Okay, so I erase this one. Then from here we need to differentiate, we need to differentiate this one. Okay, so differentiation of this one will give us, this one is equal to u as cos n pi over 2 delta multiplied by pi over 2 delta. And since cos n pi equal to 0, so cos n pi is 0, so cos 0 is equal to n pi equal to 0, so cos 0 equal to 1. This one equal to 1, so we have here only u as pi over 2 delta. This is the du dy. So from here we can transfer to here, which is the shear wall equal to mu us pi over 2 delta. That's one thing that we solve there. And again, from the question, they ask to use integral momentum equation as a tool to solve the rest of the question. So from the integral momentum equation is equal to shear wall over rho us squared equal to d theta over dx, where the theta is already given as 0.1366 delta. So we substitute all the value that we obtained previously, which is that shear wall is mu, this one is this one. So we have mu us pi over 2 delta multiplied by 1 over rho us squared equal to d 0.1366 delta over dx. So we can make it simpler. This one we can cancel. So the rest we have mu, sorry, I write down the good way. Mu pi over 2 delta rho us equal to d over dx 0.1366 delta. And we try to simplify, which is that we bring what we call in differential equation spread-variable method. So we bring delta, we have delta here to this side, and the rest of the other equation to this side. Okay, so we have here, I put the delta in the at the left hand side. We have delta d delta delta d delta equal to mu pi over 2 rho us multiplied by 1 over 0.1366, something like that. Or we can multiply 0.1366 with 2. We have here mu pi over the other one is dx here, belong here. So we have dx here. Mu pi over try to multiply 2 multiplied by 0.1366 equal to 0.2732 rho us dx here, like that. And if you want to look at in more simpler, this one basically is equal to 1 over 0.2732, which is that 1 over 0.02732 equal to this one 3.66. So we can write down that's one. This one is equal to 0.366. Oh, sorry, 3.66. Second, 3.66 mu pi dx over rho us. Okay, so this one is del d del. So from here we have to differentiate here d delta and dx. We can integrate both sides. Integrate both sides. We have integration the integration of del d del equal to the integration of 3.66 mu pi dx over rho u s. Okay, so from here we got del square over 2 is equal to 3.66 mu pi x over the dx over rho u s. Okay, so from here we can have delta squared 2 you go to here equal to 3.66 multiplied by 2 equal to 7.32 mu pi x over rho us. So delta is equal to the square root of 7.32 mu pi x over rho us. Okay, from here we can see that this one is constant because we have all the value for that one. So we can simplify as 7. 15 is better. Okay. Sorry. 7.32 mu pi over rho us we can write down as equal to a. So we can write down here square root of a x, or a here. I think we can straight away calculate the value of a, which is that 7.32 multiplied by mu from the question we have mu equal to 1.71 times 10 to the power of minus 5 multiplied by pi over rho is 1.29 multiplied by u stream is 35. So from here from my calculation I got 2.951 times 10 to minus 3. Okay, this one is the a. So we let it here. So when we use it later, so we have this kind of equation. No. Okay, this one actually square root. Yeah, like this. Okay. So when we have this one, basically we can write down as ax 1 over 2. Remember that we have the equation for shear wall. Where is the shear wall? Which is that where's the shear wall? Okay, sorry, this one. We have this shear wall. So right now we already got this value of delta. So we substitute into that equation. So again I write down here shear wall equal to mu us pi over 2 delta, which is that delta we already got as this one. We got mu us pi over 2ax 1 over 2, and fd from the beginning, which is from here. We got the shear wall we need to integrate from 0 to L. Shear wall is mu US pi over 2ax 1 over 2 dA. Sorry, dA. We need integrate to with respect to a. So basically dA. Sorry, maybe I missed something here. We have x, we have a. Okay, so dA actually equal to dx multiplied by 1 unit. So this one also we can write down as 0 to L mu US pi over 2ax 1 over 2 dx. So that we have the function of x, we have the del x, so we can integrate that one. So integration of this one will give us basically what we want to integrate, only the x, so very easy. Mu US pi over 2a integrate, sorry, the integration of 0 to L 1 over x 1 over 2 dx. Basically it's very simple, not because all this thing is constant, we have the value for that. Sorry. Okay, so from here when we solve this integration, we have mu US pi over 2a is 2x 1 over 2, which is from 0 to L. Then we substitute the limit, so we have maybe here a little bit mu US pi over 2a 2L 1 over 2. So because of 2, we have mu US pi L 1 over 2 over a. So from here we see that all the value we already obtained here. Again we substitute the value. Mu we have 1 over 6.1 times 10 to the power minus 5 multiplied by US. U stream is 35 multiplied by pi multiplied by L over 1 over 2, L to the power of 1 over 2 over a. Yeah, we already got a here, this one. A is 2.951 times 10 to the minus 3. So from my calculation here I got 0.6371 L 1 over 2. Okay, remember what is the value of L? We're not sure yet. So at the beginning they said that at the boundary layer thickness, at trailing edge is equal to 2 mm, which is that delta equal to 2 mm at x equal to L. Okay, so here we want to determine the value of x here, or L at x equal to L. So again we have this boundary layer. We already got one of the question of the boundary layer, which is the simple one I got. Okay, here maybe we can use this one, or yes, maybe we can use this one. So we have here delta square over 2 is equal to 3.66 mu pi x over rho us. So from here, x equal to x, okay, delta square rho us over 2 multiplied by 3.66 mu pi. This one, delta here is 2 mm or 2 times 10 power minus 3 meter, 3 square. Rho is 1.29 multiplied by u is 335 over 2 multiplied by 3.66 multiplied by mu is 1.71 times 10 to minus 5 multiplied by pi. So here you got here x equal to 0.46 meter, which is that we have the airfoil from 0 to L. So here L equal to 0.46 meter. So last we substitute into the drag force equation. We have Fd equal to 0.6371 multiplied by 0.46 power of 1 over 2, which is that give us 0.4321 Newton. That's all for the solution of example 6. So try to look at, try to understand, and try your best to understand. Thank you.